Hello, my name's Luis Gabriel Rodriguez Valdez, and I'll be talking about homological theory of k-idempotent ideals in dualizing varieties. This is a joint work with my advisor, Professor Valente Santiago Vargas at Universidad Nacional Autónoma de México. This work can be consulted in this preprint. The main inspiration of this work is the paper Homological Theory of Idempotent Ideals by Auslander, Placzek, and Todorov. They defined k-idempotent and strong idempotent ideals in arting algebras, as shown here. In this definition, they used the canonical morphism phi, which are induced by the adjunction of the inclusion of mod lambda over I in mod lambda and the functor trace of lambda over I. Now we want to define k-idempotent and strong idempotent ideals in C dualizing variety. But first, we need to define the functor pi star between mod C over I and mod C. We define this functor as the composition with pi, the canonical projection. Now, we are able to define the concepts of k-idempotent and strongly idempotent ideals in a dualizing variety, which, as seen in the definition, are totally analogous to the ones seen for arting algebras. To generalize the results of Auslander, Placzek, and Todorov, we need an extra property, which we call property A. This property tells us that for every object C in the dualizing variety, there exist epimorphisms as shown here. And this proposition shows that when the ideal I is the ideal of morphisms which factor through some additive full subcategory X of the dualizing variety C, I satisfying property A is equivalent to X being functorially finite in C. And now, with this property A, we can generalize different characterizations of k-idempotent ideals that we have in the context of arting algebras. That is, given a dualizing variety and an ideal which satisfies property A, we have these statements are equivalent. The ideal I is k-idempotent. These X functors are equal to 0. Dually, we have these Tor functors are equal to 0. And similarly, as what happened with the morphisms phi, we have these psi morphisms are isomorphisms. Now, let's see the concept of trace ideal associated to a projective module. As we'll see soon, this is quite important because using this ideal, we will obtain a recalment. We define this ideal using the trace of the projective module in each representable functor. Then, using the trace ideal, we obtain this recalment where P is a projective in mod C, B is at C, and this algebra is the algebra of endomorphisms of P. In the left side, we have the ideal IB, which is the ideal of morphisms in C, which factor through objects in B. And moreover, IB is precisely the trace ideal. To obtain the next result, we need the following definition. Given P a projective module and a non-negative integer K, we define Pk as the full subcategory of mod C consisting of the C modules having a projective resolution with Pi in at P, where I goes from 0 to K. This proposition characterizes the property of the trace ideal being k+1 idempotent in terms of the belonging of this module here to Pk for all objects in the dualizing variety. Now, let's see the relation with quasi-hereditary algebras. If we have a dualizing variety with co-kernels and the hypothesis that for every object C prime, this module is projective, then we get that the ring of endomorphisms of P is quasi-hereditary. Finally, if we have the dualizing variety, the projective P and the trace ideal using the functor pi star, if this functor is projective, if this module is projective for all C prime in C, we can obtain a full embedding of the bounded derived category of mod C over I in the bounded derived category of mod C. Well, this is the bibliography we used for this work. Okay, thank you for watching the video.